In our last video, we talked about sampling, and we discussed all the different ways that we can collect data, and talked about sort of the benefits of each and the ultimate goals of each, and some of the drawbacks of each approach that we could take. In this section, I want to talk about the types of data that we can actually collect, because depending on the type of data we're dealing with, we will have to treat them differently, and we'll see this in some of the upcoming sections. So to apply statistics to different types of data requires different approaches. So let's talk about some of the types. Before we jump into that, I want to just get a bunch of definitions out of the way. Some of these we've kind of talked about in the last video, but this is just going to be a big chunk of writing, and then once I've got all this written down, we'll look at a concrete example to hopefully put these into context. Okay, so if we start with just a big collection of data, a collection of data is called a data set. So if we've collected a bunch of data, that data all grouped together is what we're calling our data set. The information that we collect, or the data that we collect, sorry, my pen is acting up here. Let me try this again. There we go. So information is collected on what we call individuals. And this was a term that we talked about last time. I said it can be people, but it doesn't have to be. So as an example, it could be people if we're doing a study about people. Maybe it's plants if we're some sort of botanist or something. Rocks. Or it could even be like a collection of events. So the results of coin flips. Any one of those types of things can be what we refer to as an individual. So we collect information on these individuals that are members of the population, which is the group that we're trying to study. And which together make up the sample. So that's what the individuals are. The individuals make up the sample. All of them are members of the population. The characteristics that we're interested in studying about these individuals, so the characteristics or types of outcomes or result or information that we collect from these individuals is what we call variables. So that characteristics are called variables. And so this has a very slightly different meaning than what you might be accustomed to in another math class. The variables are just sort of generic placeholders for the categories or the types of information that we're interested in collecting. The actual values of these characteristics, so the actual data that we collect, so the actual values of these characteristics that we're calling the variables are the data that we're collecting. And so I just want everybody to be comfortable with these words and know what they mean. We've got a data set, which is just a big collection of data. The individuals are the either people or items or events that we're studying. The characteristics that we're interested in from those individuals are what we call variables. And then the actual values of those characteristics are the data. So let's do a quick example to make these a little more concrete. I want to imagine that we're doing an example similar to the one that we talked about in the last video, where we are looking at voters, and maybe we're interested in surveying some people, finding out which political party they're affiliated with, which candidate they plan on voting for, and maybe how old they are, or something like that. So polling likely voters on the following info. So maybe we collect our data and put it into the following table. We have the voter, and we typically could either collect their actual names, or maybe in this case we want it to be anonymous, so we'll just assign them. Here's the first person we talked to, the second person, the third person, fourth person, fifth person, sixth person, and so on. We'll ask for their party affiliation. We'll ask for who they plan to vote for. And we'll ask them what's their age. And we'll put them into a table like this. And maybe that first voter that we talked to, it turns out that they are a Republican. They plan to vote for, I'll just say, candidate A. Instead of picking specific candidates, maybe it's a local election, so generically speaking, candidate A. Let's keep this as general as possible. And maybe this person is 52 years old. And the second person that we talked to is also a Republican. They also plan on voting for candidate A, and they are 33 years old. The third person we talked to is a Democrat. They plan to vote for candidate B, and maybe they're 19 years old. The next one is maybe an independent, and they plan to vote for candidate B, and they're 47 years old. And then we've got another Republican, and maybe they're going to vote for candidate B, and they're, 28 years old. And we've got a Democrat that's voting for candidate A, and maybe they're 75 years old. Whatever the case may be. That's, I think, enough. Let me trim this down a bit. So this is the idea. In the context of this poll, I want to figure out what all of these definitions are. So, as we go through this thing, I want to start off with the individuals. The individuals are in this case, people, the voters that we're studying. So that is this category over here. These are our individuals. So our individuals are the voters. The characteristics that we're collecting information about are their party affiliation, who they plan to vote for, and their age. So all of these things up here, these are the variables. All the stuff along the top. Maybe I'll do it in a color here. So all of these are the variables. And maybe I'll do all of these just to make it totally clear. These are the individuals. And the actual data are all these individual pieces in here. So maybe that, all of these. I'm just going to point at a few random ones, but all of the stuff that actually got filled into the table, that is what makes up the data. And this whole collection is what we call the data set. So the whole collection, the whole table is our data set. So this is the idea. That's how those variables, how all of those words get defined in the context of an actual example. Variables, data, individuals, data set. So what are the actual types of data that we can collect? Now that we've got this out of the way, what are the types of data? We're going to break it into two main categories. The first is what we're going to call qualitative data, And when we talk about the categories we're interested in, this would be qualitative variables, so qualitative data or qualitative variables versus quantitative data. And luckily, the words, even though they're big and scary, you can probably guess at what they mean. If you look at the root of qualitative, the word that you might recognize is qualities. We're looking at the types of qualities that we might be interested in. So these are like categories or qualities. So let me just write it that way. Qualities is probably a better word to use. So qualities of an individual. Whatever, let's do both. Qualities or categories. And quantitative data, the root word there is quantity. So we're talking about numbers. So the easiest way to distinguish between them is basically quantitative data is numbers, qualitative data is everything else. So for example, if we look up at the example that we just did, and I'm looking at party affiliation, who they plan to vote for, and the age, their party affiliation, Republican, Democrat, Independent, that's going to be qualitative data. Those are sort of categories. Same with the candidate that they plan on voting for. Candidate A, candidate B, and so on. Those are sort of categories that they're falling into. Whereas their age are very clearly numbers, and so that would be quantitative. So if we look at examples of each of these, for the top one, it can be the party affiliation, who they plan to vote for. More generally, outside of this one example, if we're studying some sort of, physical features of people, we could be talking about hair color or eye color. There's a whole bunch of things, but anything that's not a number. Over here we had age. Again, it could be other things. Height is a number. Anything along these lines. What else could I do? Age, height, weight. Anything where the outcome is a number would be considered quantitative data. So each of these categories then has two subcategories. So I'm going to actually, let me cheat and give myself a little bit of room here. I'm going to pull this down a little bit and make more room. The nice thing about using a whiteboard like this. And let me come back and erase that. I'm going to put the subcategories right in here inside of each of these. So under qualitative data, there's going to be two subcategories of qualitative data. There's what we call ordinal and nominal. So ordinal qualitative data and nominal qualitative data. And again, if you look at the roots, the root of this first one can kind of give you a hint as what it's talking about. Ordinal data is data that has some natural order to it. So there's some sort of hierarchy. And nominal data has no order to it. So if we look at the examples I just did here, party affiliation, who they plan to vote for, eye color, those would all fall into the category of nominal data. There is no natural, universally agreed upon hierarchy of this is best, then this, then that. Right? We can't say Republicans are better than Democrats or better than independents. You're going to get a lot of disagreement. There's not a universal agreement in that case. So the ones that we've looked at, things like eye color, it's not best to have brown eyes, then green eyes, then blue eyes, right? There's no agreed upon order in that case. So most of these that we just looked at all fall into the category of nominal data. So eye color, again, political affiliation, etc. There's no natural order. So it's harder to come up with ones that do have a natural order. But some easy examples of this are things like letter grade. Again, it's not a number. A is better than B is better than C is better than D, and so on. So letter grade, there's a natural order. Maybe drink size or t-shirt size, large, medium, small. Things like military ranks or police ranks, which I'm not super familiar with, but obviously general is better than whatever, corporal is better than admiral. I don't know how they go, but somebody will know. So military rank. Notice all of those are just words. They're not numbers, but there's still some natural hierarchy to those words, that this is better than this is better than this, or this is above this is above this is above this. Quantitative data, on the other hand, when we're dealing with numbers, it always has order. Order's built into numbers automatically. That's the whole point of having a number system, right? 1 is less than 2 is less than 3 is less than 4. Numbers are ordinal no matter what. But there are still 2 subcategories of quantitative data that we're going to be interested in, and they come from sort of mathematical definitions. We can think of what we're going to call either continuous variables, continuous data, or discrete. And in mathematics, what these words refer to is basically whether or not there's gaps between the numbers that we care about. So in this case, discrete has gaps between the possible values. If you read the book's definition, it's a little bit different, but I think this is a clearer, easier way to understand it. In discrete data, there's gaps between the possible values. In continuous data, there's no gaps. And these can be kind of tricky, discrete versus continuous. If we look at the examples that we have here, age, height, weight, etc., all of those categories can be treated either way, and it's going to be context dependent whether we're considering this data to be discrete or continuous. So what do I mean by that? If we're talking about what is your exact height, we're going to need to include all those decimals. Maybe you are, 68.237948 whatever inches tall. If we care about all those decimals, we're treating it as continuous, and that's the way that we actually grow, right? You started off as a baby, maybe 19, 20 inches tall, and you grew continuously. You didn't grow in discrete chunks where one day you were 2.5 feet tall, the next day you were 3 feet tall, the next day you were 3.5 feet tall, and you eventually made it to 5.5 feet tall or something like that, going in chunks. So if we care about the decimals, then we would treat all of these as continuous. So I'm going to use the word exact. This is going to be kind of the important keyword. If I'm interested in your exact age, not just rounded to the nearest year, not the age that you turned at your last birthday, right? Not that you're 19 years old, but that you are 19 years, 4 months, 17 days, 21 hours, and 32 minutes, and 15.7 whatever seconds old. If I care about your exact age, that is continuous. We age continuously. So exact age, exact height, exact weight, right, etc. If I care about the decimals, we are keeping all the decimals. If we're keeping all the decimals, we're treating that as continuous. On the other hand, most of the time, if I ask you how tall you are, you won't tell me that you're 68.23794 ... inches tall. You'll just say Yeah, I'm 5'8". I'm 68 inches tall, 5'8". We will round to the nearest inch. So if you look on your driver's license, it's to the nearest inch. It's to the nearest pound to your weight, and so on. So if we're talking about rounded, and often we're dealing with these as rounded age, height, weight, etc., where we don't keep all the decimals, or round it off after only 1 decimal or something like that. That would be discrete. There's gaps between the possible values, right? You go from 5'8" to 5'9" to 5'10". Most people don't include the extra half inches or decimals of how many inches in between those two heights are. Most people will just round up. But there are a few things that can't fall into both categories. So anything that's continuous, if we just decide to kind of round it off, we can treat it as though it were discrete. But there are some things that can only be discrete that can't be treated as continuous. So for example, if I ask you, how many credit hours are you enrolled in this semester? There aren't decimal options for that. It can only be a whole number. You can be taking 12 credit hours or 15 credit hours or 3 credit hours, but you can't be taking 7.264938 credit hours. So there are some other examples, things like credit hours. How many doors are on your car? How many siblings do you have? And even if you count half siblings as halves, that would still be discrete. So we're allowed to keep decimals as long as there's still gaps. Even if you're counting half siblings and you can have 2.5, well, you can have 2 siblings or 2.5 siblings or 3 siblings, but you can't have anything in between the 2.5 and the 3. There's still gaps, even though they're not whole number gaps anymore. So number of siblings, credit hours, how many doors are on your car, etc. Those are all examples of things that can only be considered discrete. There's no way to include extra decimals on these and treat them as though they were continuous. So that is the idea here. That pretty much sums up everything we need. One visualization that I think helps some people is doing this as sort of a tree diagram. So if we talk about all the different types of data as just a quick summary, we really are breaking it into 2 categories. We have our qualitative and our quantitative data. And then each of those 2 things is further then broken into 2 subcategories. And so for qualitative data, we have ordinal data. We have nominal data. So ordinal, again, means ordered. Let me write the word, concentrate on what I'm doing, nominal. So ordinal data, there's a natural order. Nominal data, there is no natural order, but they're both subcategories of qualitative data, categories, not numbers. Over here under quantitative data, numbers, we can either care about decimals or not care about decimals. So we have continuous, and we have over here discrete. Oops. So this is a way to kind of think about how the types of data are organized, big picture-wise. And as I said, we will treat qualitative data differently than we will treat quantitative data. And down the line, even later, we will treat, for example, continuous data differently than we will treat discrete data when we start applying actual math to it. So we'll see that later on in the semester.